What's good, everybody? In this video, we're going to be talking about dividing exponents. So I'm going to show you how to divide exponents and what to do in case our answer gives us a negative exponent. We really hope you find this video helpful. So we're talking about problems like this. Say we had x to the fifth divided by x to the eighth. So these are the type of problems we're talking about when we talk about dividing exponents. But before we answer this, let's take a look into the rules of dividing exponents. So you'll see something that says a of m divided by a of n. And typically what you're going to do is subtract that bottom exponent from the top. In this video, I'm going to replace a with x because we typically use x and y in those variables. So let's say we have x to the a power divided by x to the b power. What happens is we're going to do x to the a minus b, and that's going to give us our new power, x to the c. Now let's say, and I made up the c, guys, that's just the answer. But let's say now that when we subtracted, we got x to the negative c. We know that we cannot have a negative exponent. So the way that we take care of this is we turn this base and exponent into a fraction by putting it over 1. And then we're going to take that base and exponent, bring it down to the bottom, bring 1 to the top. Basically, we are taking the reciprocal. So as a result, our answer will be 1 over x, and now c becomes positive. So this is the rule that we're going to be using to answer these type of exponent questions. Now, what I'm going to do in my video is show you guys different methods in which we could solve this. So let's look at our first example, right? And I'm going to switch to a number now, a base. So let's say we had 2 to the second power divided by 2 to the fourth power. So in our first approach, the way that you could handle this or solve this is writing it out, right? So we have 2 times 2, that's 2 to the second power. And then 2 to the fourth power, we know we're multiplying 2 by itself 4 times. Now, after we do this for the first approach, we could go ahead and cancel, right? That 2 with that 2 cancels. This 2 with this 2 cancels. So even though we don't see a number in the numerator, we know that there's an understood 1. But we want to focus on the bottom because what's left over is 1 over 2 to the second power. And when we go ahead to now solve this, finalize the problem, this would be 1 over positive 4. And that would be our answer. Now, in not problem number two, I'm sorry, approach number 2, my favorite method, what we do is we set it up. So we have 2 to the second power divided by 2 to the fourth power. So what I'll do is follow the rule and apply this step here. So we know our base is 2. I'm going to take that second power, subtract the fourth power, and as an answer, we're going to get 2 to the negative second power. Now at this step, we know we cannot have a negative exponent, so Mr. Peters is going to make this into a fraction. Make it into a fraction, I take the reciprocal, so now I have 1 over 2, and our power becomes positive, and once we simplify one more time, we have 1 over 4 as a final answer. Now, what we're going to do is show you the third approach, right? So this is approach number 1. We could write it out. I don't recommend that, guys. Please don't do that. It's going to take too much time if the exponents are high, like 10 or 15. Approach number 2, that is Mr. Peters' favorite. But now we're going to go into approach number 3, and this is to kind of get rid of the negative exponents altogether. But there's a very specific way and rule that we have to follow. So this approach number 3 only works when the bottom exponent is larger than the top because we're going to have a negative exponent as a result. So what we could do is we could take the reciprocal of 2 to the second power. So what does that mean? We have 1 on top, we have 2, and remember, if we take the reciprocal, right, if it's positive, it's now going to be negative. So we have 2 to the negative second power, multiply by 2 to the fourth power. So when we're multiplying exponents and they have the same base, we just add our exponents. So negative 2 plus 4 is going to give me 1 over 2 to the second power, and that is going to be equal to 1 over 4. So these are three approaches that you guys could use to solve when we're dividing exponents. Now, in the second part of this video, we're going to focus on the second rule and we're going to apply that rule to some practice problems. In our practice problem now, guys, we're going to apply that rule that I spoke about. So when we look at the first example, right, I have z to the eighth power minus z to the fourth, and as a result, I'm going to get z to the fourth power as an answer, right? And we know this is not going to be a negative exponent because the exponent in the top is larger than the exponent in the denominator. Now, when we go over to problem number 2, first thing we need to understand is that if there is no exponent, like there's no exponent over a, there's always an understood 1. So when I go ahead to solve, I have a to the fifth power minus 1, which will give me a to the fourth power. And then when I look at b, this is where our negative exponent rule is going to come in hand. So I have b to the second power minus b to the fourth. And as a result, I'm going to get b to the negative 2. So how do we actually express this final answer? So after subtracting, what we'll have is a to the fourth, b to the negative 2. So we know b cannot stay there, right? We know it can't stay there because they have a negative exponent. So we're going to follow our rules. We're going to turn it into a fraction, and we're only going to bring down the term, or the base, I should say, with the negative exponent. So only b to the negative 2. A to the fourth is going to stay the same. So my final answer will be a to the fourth all over b to the positive 2. And that'll be it. We can't do anything further with these exponents because there's different bases, okay? And please understand that this rule only applies if we have the same base. If this was z on top and w on bottom, we could not do anything at all. Now, in my next examples, we're going to be working with properties of exponents and dividing, but there's also a coefficient. But what I want you guys to know is that the coefficient acts like a regular fraction. So what does that mean? Glad you guys asked. We're just going to reduce. So I know if I divide both 4 and 12 by 4, I'm going to get 1 over 4 as my fraction. Now when I focus on my exponents, I have x to the fifth minus 3, which is going to give me x squared. So let's put that up here. And then we have, remember, no exponent for y, so we know it's assumed 1. So I have y to the first power minus y to the second power, and that's going to give me y to the negative 1. So now at this step, this is my answer. But there's two things that is wrong with the way we wrote or expressed this answer. Number one, we don't have to put 1 if there's other terms in the numerator. Number two, we can't have this negative exponent. So what does this mean? Really glad you guys asked. So let's go ahead now and solve this. So at this step, what we're going to have is x squared all over 4y. Remember, we do not need to put that exponent of 1 because it is understood. And now we're going to move to our last, not our last example, but the last example on the board. Oh, and I made a mistake. Well, hold on. This is why you got to double check your work. This should be 3. So if anybody caught that in the video, I'm sorry, I do make mistakes. I don't know what I was thinking. This should be 3. So x squared over 3y. That's why it's important to double check your work. Now the last problem, we know 18 divided by 9 gives me 2. And then when I look at my exponents, I have x to the 8th minus x to the 10th power. And this is going to give me x to the negative 2. So when I combine this with my answer already, we'll have 2x to the negative second power. And as a result, let's just get some more space. Let's erase this real quick. I'm going to turn this into a fraction, and then that x to the negative second power is going to come down to the bottom. So the final answer will be 2 all over x to the second power. But before we go and we wrap this video for you guys, we're going to look at one more problem, which is going to be a little bit more challenging, but this you're definitely going to see on your test or your exam. So stay tuned. Last problem of this video, guys, and like I said, really hope you've been enjoying this video and you find some value. If you have, just smash the like button for us so we know that you find this video helpful. So I like to go over a problem like this at the end of the video because this is what you're going to see. They're typically not just going to give you a fraction where you subtract because that's very simple. They're going to mix the rules together. So in a problem like this, there's a few things going on before we could subtract. So we're doing a power to another power, meaning we're raising an exponent to another. So to solve this, I need to take everything inside here to the fourth power. So 2 to the fourth power, right? We do 2 times 2 times 2 times 2, we're going to get 16. And after I multiply my exponents 2 and 4, I'm going to get x to the 8th power all over 10x to the 15th. Now at this stage, guys, there's a lot of things we could do, but we'll still get the answer if we do the right steps. We could simplify 16 and 10 first, or we could take care of the exponents. What I'm going to do is take care of the exponents first because I'm more worried about that, and I think that's the harder part. So I have x to the 8th power minus x to the 15th, and this is going to give me x to the negative 7. So what I'm going to do is now rewrite this. So we have 16x to the negative 7 all over 10, right? We took care of our exponents. Now, next thing I want to do is take care of my negative exponent. So once we go down here, we'll have 16 all over 10x to the positive 7 power. And now that I took care of my exponent, we can now reduce this fraction. And when I'm looking at this, I think the best thing to do is to divide 16 and 10 by 2. Once we do, let's just write this over here so I make sure you guys see this. We're going to get 8 over 5x to the 7th power. And this will be our final answer for this problem. And like I said, this is typically what you're going to see when we're dividing exponents. Really hope this video was helpful for you guys today. Thank you so much for joining Algebra 1 with Mr. Peters. Smash the like button for us, subscribe to the channel, and leave comments, for future videos you guys would like to see on our channel. Or if you just had a question from today's video, thank you guys so much for joining us today.